Warm greetings to our esteemed teacher and my dear peers. I, Devanshi Agarwal of class 7D, am going to demonstrate and explain two physical and two chemical changes. The name of the first activity which betrays a physical change is the making of a paste of sandalwood powder. The requirements of the activity are a certain amount of sandalwood powder and water along with a small container to make a paste of both the components. Water and sandalwood powder should be in the ratio of 2:1. To make the paste, we have to mix both the components. The result of this step will be a homogeneous mixture of sandalwood powder and water. This is a liquid state. Liquid paste, which when kept under the sun, dries up and forms a hard layer. If this layer, when smashed a little, changes into the same powdery form as it was earlier. If the sandalwood powder, which was used in the very first step, compared to one which was formed in the last step, looks exactly the same. They are twins. Now let's know why we call this activity as a physical change. When both the components, sandalwood powder and water, were mixed, a change occurred which did not lead to the formation of a new substance. Instead, we received the liquid form of sandalwood by mixing water with it. So we can say that no new substance was formed. The composition of the sandalwood powder before getting mixed with water is as same as the sandalwood powder paste. The molecules of this substance were not combined by molecule or molecules of any other substance before or after the change. Thus, the composition remains the same. If we smell the sandalwood powder and the paste, we come across no difference. Even the color of the powder as well as the color of the paste remains the same, which is saffron. So there is no change in the properties as well. As we saw in the activity that the sandalwood powder when converted into a paste is a change, and this change can be again transformed into its initial form by changing the conditions. This means that the paste can be again converted into its powdery form by drying it under the sun or by providing it with heat. Here we are changing the conditions by providing the paste with heat. There are also changes in the physical properties. The solid state, which is the powdery form, has just been converted into liquid without disrupting its original properties or composition. Energy is involved in this change. How? Heat is a form of energy which is involved here. It has been used to dry up the paste. The source of heat here is the sun. The name of our second activity which betrays a physical change is the converting rock sugar into its powdery form. The requirements of this activity are a hand grinder, a piece of rock sugar changing into its powdered form. Rock sugar, where it forms a hard and a big solid. Rock sugar forms a hard and a big solid which when grinded and smashed in the hand grinder gets converted and changed into powdered sugar, which is a way more soft and tiny substance. Now let's know, why do we call it as a physical change? When rock sugar smashed and converted into its powdery form, a change occurred which did not result in forming any new substance. The amount of molecules which was contained in the rock form of sugar was same in its powdered form. Thus, there was no change in both of their composition. The rock sugar's property is somewhere identical to its powdery form. This is because the rock sugar tastes sweet and so its powdery state. Rock sugar when charged turns into a black mass and so when the powdered sugar. When this change occurs, the rock sugar can be converted into powdered form, but powdered sugar cannot change back to its rock form. This is the reason we call it an irreversible change, as this change cannot be reversed and becomes permanent. There are changes in the physical properties. Why? The rock and hard sugar is different from the tiny particles of powdered sugar. The color has also changed from golden brown, which was of rock sugar, to whitish brown, powdered sugar. How is energy involved here? Mechanical energy, which was used here to smash the rock sugar and to perform the change, has been involved. Now let's start our first chemical change activity, which will be very interesting. The name of the experiment is Volcano. Things which will accompany this activity are a glass filled with 2/3 of water, dishwashing liquid, around 5 to 6 tablespoons of baking soda, and lemon juice. After adding all the components into water, we experience a very exciting procedure where foams are formed and are expelled out of the glass. Now let's know, how is this experiment a chemical change? Let's analyze it. This is definitely a permanent change. Why? This is because the foam which is formed during the change cannot be converted back into its constituents. Thus, the foam remains in the same state forever. There are many new substances formed during the chemical reaction. The bubbles which were formed during the experiment indicates that there were air bubbles escaping, leading to the evolution of carbon dioxide, forcing the foam to spill out of the glass. In this experiment, molecules of different substances chemically bonds with other substances, summing up all the reactions taking place in this experiment. A chemical equation has been evaluated and noted below. As you can see in the right hand side, there is a chemical reaction. This chemical reaction evaluates this. The properties are totally different from the reactants and the product. The foam formed is liquidly, but some of the reactants like baking soda is solid. From the chemical equation, we know that the product is combined chemically with many other substances, like the chemical composition highly differs. This change cannot be reversed from the product, which is the foam, to its constituents. Thus, it is a chemical change. How is it an endothermic reaction? An endothermic reaction is such kind of a reaction where heat is released. Thus, if we note the temperature of the mixture after every 20 seconds, we will notice that the temperature decreases constantly. Thus, this reaction is an endothermic one, where the byproduct is heat, where it releases heat. Another reaction which takes place in our daily lives and is often performed in our kitchen to make different ingredients like paneer, sandesh, chena, etc., is curdling of milk. Things required in this activity are citric acid, milk, and a spoon to stir. If we add 2 teaspoons of citric acid, boiling milk, we will observe white lumps forming on the surface of milk in the corner of the vessel. This betrays that the milk has curdled. Let's know the reason to call it a chemical change. It is a permanent change, as when the milk once curdled cannot be changed back to the original milk and remains the same way after adding the citric acid. This change leads to the formation of a new substance with a white clumps called curdles. Thus, it can be said as a chemical change. The physical and chemical properties are totally different. As the curdles are more acidic, which is not level to that of the original milk, we can say it as a chemical change. The pH also drops with the milk curdles, so it is totally different from those of its constituents. This is an irreversible change, as after the milk has been curdled, we cannot get back to the original milk after the chemical reaction takes place. I do hope that you liked my presentation and got a fair idea of what chemical and physical changes are and what all we can observe in our surroundings as a change. Changes are important in our lives. Thank you so much. Keep creating, keep experimenting, keep thinking. Thank you.